Hello everyone. Welcome to the mini lecture on electromechanical control technology. Today, we will study how to select an AC motor. In this lesson, we will cover the following topics. Through this lesson, you should be able to clearly identify the key factors to consider when selecting a motor, such as determining requirements, choosing the type, and calculating power. You should also be able to explain how these factors affect motor performance and make an informed decision based on actual needs. You will be able to choose the appropriate AC motor by comprehensively considering various factors according to actual needs. Motor selection involves determining requirements, selecting the type, calculating power, rated power, voltage and frequency, speed, size, protection rating, thermal protection, and control methods. Choosing the right AC motor can greatly help improve equipment efficiency, save energy, and reduce operating costs. So, please take a moment to think about what you consider the three most important factors in the AC motor selection process. Motor selection is a crucial step for engineers during the design process, as it directly impacts the product's performance, reliability, and cost. Now, let's go through the detailed steps of motor selection. Let's look at the content related to motors. 1. Determine requirements. First, we need to clarify the basic information such as the motor's purpose, working environment, operating mode, and type of load. This information will help us choose the appropriate motor type, e.g., AC motor, DC motor, stepper motor, etc. 2. Select the motor type. Based on the requirements determined in the first step, we can choose the appropriate motor type. For example, if precise position control is needed, a stepper motor can be selected. If high-speed rotation is needed, a brushless DC motor, BLDC, could be an option. 3. Calculate load power. Based on the torque and speed of the load, we can calculate the power required by the load. The load power can be calculated using the following formula. P equals T times N divide 95/50, where P is the load power in watts, T is the load torque in Newton meters, and N is the load speed in revolutions per minute. 4. Select the appropriate rated power. The motor's rated power should be greater than the load power. It is generally recommended to choose a rated power 1.1 to 1.5 times the load power. This ensures that the motor will not be overloaded during normal operation, thus extending its service life. 5. Choose the appropriate rated voltage and frequency. The motor's rated voltage and frequency should be selected according to the supply voltage and frequency. For example, if the supply voltage is 220 volts and the frequency is 50 Hz, a motor with a rated voltage of 220 volts and a rated frequency of 50 Hz can be selected. 6. Select the appropriate rated speed. The motor's rated speed should be chosen based on the speed requirements of the load. In most cases, the motor's rated speed should be close to the load speed. If there is a significant difference between the load speed and the motor's rated speed, consider using a reducer or gearbox to adjust the speed. 7. Select the appropriate size and weight. The motor size and weight should be selected according to the available installation space in the operating environment. If space is limited, a smaller sized motor can be chosen. If the operating environment has high requirements for noise and vibration reduction, a heavier motor can be selected, as heavier motors typically have better vibration and noise suppression capabilities. 8. Select the appropriate protection level. The motor's protection level should be chosen based on the operating environment. The higher the protection level, the better the motor's ability to guard against external environmental factors. For example, if the motor needs to operate underwater, an IP68 rated motor should be selected. 9. Select the appropriate thermal protection. During operation, the motor generates heat, and if this heat is not dissipated effectively, it may cause the motor to overheat and become damaged. Therefore, it is necessary to choose an appropriate thermal protection method, such as using thermal relays or thermal protectors. 10. Select the appropriate control method. The motor's control method should be selected based on the actual requirements. Common control methods include open-loop control, closed-loop control, speed control, and position control. Choosing the right control method can improve the motor's control accuracy and response speed, thereby enhancing the overall performance of the system. In conclusion, motor selection is a comprehensive process that requires careful consideration of actual needs and working environments. Only by selecting the appropriate motor can we ensure optimal performance in practical applications and enhance the overall competitiveness of the product. Through today's lesson, we have learned the key factors and steps involved in selecting AC motors. Correct motor selection not only affects the motor's performance, but also directly impacts the overall efficiency and competitiveness of the equipment. I hope that in your future work, you can apply today's knowledge flexibly, contributing to the development of equipment and products. Additionally, feel free to share any challenges or insights you encounter during the motor selection process, so we can learn and progress together. Lastly, please think about this lesson and complete the following exercises to consolidate today's knowledge points and deepen your understanding. That concludes our lesson for today. See you in the next lesson.